Hello Legacy Sabers, Marsh here. So today we're going to graph square and cube roots. You want graph paper and notes, the foldable I gave you for that is, pen or a pencil, and then you also want possibly a calculator just to see where I'm getting some of these numbers from. So, just to review some ideas to keep in mind, when we did an x cubed or a polynomial graph, we had a graph that looked something like this, right? Looked something like that consistently when it was an x cubed. An x squared was our parabola, so it looks something like that. When we're doing square roots and cube root graphs, ultimately what's going to happen is these graphs you're going to notice are going to basically be like a turned graph of the x cubed and x squared. We'll take a look and you'll see it here in a minute. So, let's take a look at the parent square root function. Well, the parent square root function is y equals the square root of x, okay? Now, there is a parent table that you're going to want to memorize for the square root function. Here's how you know what it is. Well, it's the first three square roots, which are 0, 1, and 4. Okay, so remember those, 0, 1, and 4. The answer, so if I take those and plug it in, I want to square root them. So if a square root of 0 is 0, square root of 1 is 1, and the square root of 4 is 2. So I'm going to graph that. I got 0, 0, 1, 1, and then 4, 2. So my graph's going to start here, because think about it. If I plug negative 1 in, right? I can't do the square root of negative 1. That doesn't work. So I can't plug in a number. There is no dots in this side of my graph. So it starts at this point and then it shoots off, kind of like square root graph, okay? Kind of shoots off, kind of like a shooting star in that regard. So my domain of my graph starts at 0 and it goes off to infinity. My range is going to do the same thing. Start at 0, go off to infinity. Let's answer some more questions about that. So is this function continuous? Remember, continuous means if I put a pencil down, can I draw the entire graph without picking it up? Yes, answer is yes to that. Is it even, odd, or neither? Even folds on the y-axis. Definitely not. Odd, that means the first and third quadrant need to match. Not the case. So this has to be neither. My maximum on this graph, technically there isn't a maximum on this graph because it goes off to infinity. So we would say it goes to infinity. However, the minimum would be 0, 0 in this case. Intervals of increasing, well, it starts at 0 and goes to infinity. However, we do not decrease at all. We always consistently go up. And behavior. So as I approach negative infinity, I am going to go to 0 in this case. And as I go to infinity, I am going to approach infinity in that regard as well. X-intercepts, we're going to have 0, 0, and then y-intercepts also at 0, 0 in this case. So let's take a look at some shifting. So remember, parabolas had some moving that happened. So this was just a normal x squared. This moved us down. This reflected us. This one moved us left. This one, remember, this would be a compression. If you remember when we talked about those, vertical compress moved us right 4 and then up 5. So we have to keep in mind our graph shifts because that will also show up on mine, on a square root. So the first thing we do have to remember, there's the number outside. That's the up and down outside the function to transform our graph or our table. We also have the horizontal shift, which is the left and right. Remember, a negative inside made us go to the right. A positive on the inside made us go to the left. We also had a vertical stretch or compression, which was outside, and then the final thing we had was a reflection or a negative in front of the function. So let's work through this problem here. I'm going to first write my parent table. So I got 0, 1, and 4, and then 0, 1, and 2, right? So now I got to think, how did this transform my function? It says I move right 3, and it's saying I'm moving up 4, correct? So right 3 is going to make me add 3 to each of these x values, and up 4 is going to make me add 4 to each of these y values. So I'm going to get 3, 4, 7, 4, 5, 6. So this is the graph or table of my graph that I wanted. So I got 3, 4, 4, 5, and 7, 6. So I got a graph that's going to go whee, like that, square root graph, okay? Because it's going to keep going off, kind of like a shooting star. Notice the right 3 up 4, that's my starting dot, okay? Because normally that was 0, 0, so if I would change 0, 0, I went right 3 up 4. So that is always going to be your starting dot in this regard. My domain, starting at 3, won't let me draw, to infinity, and then starting at 4 to infinity for my range on that particular graph. Let's try another one. So first thing, I'm going to write down my parent table, excuse me. There we go. Now, what's all happening? I am reflecting. I have compression, or vertical compression. I have left 2, and I'm going down as well. So when I'm taking care of these, I'm going to take care of the left and right first, because that's inside of my square root. So I'm going to go -2 on my x values. Okay. Now, I'm going to then take care of the vertical compression and the reflecting. It is a multiplication, so I'm going to multiply my y's because it's a vertical. So I'm going to multiply by a -1/2. The negative is because of the reflection. And then only am I allowed to subtract 1. So I'm going to multiply, then subtract. So I'm going to get -2, -1, and 2 for my x values. My y's, I'm going to go 0 times -1/2, that's 0, -1, that's -1, -1.5 it looks like, and -2. So my graph starts at -2, -1, and then I go -1, -1.5, and then 2, -2. There goes my graph. So it starts there and then shoots off into the corner. Notice there is no arrow on this left-hand side of the graph. It's only on the right-hand side. So my domain starts at -2 and goes to infinity. However, my range, since this is going down, starts at -infinity and goes to -1. So keep that in mind as you're looking at it, all right? Now, let's take a look at a cube root graph parent. So, cube root graph is going to look something like this for a parent graph, cube root of x. Now, just like our square root graph, we want to keep in mind all of the cube roots. And you're going to want to use 5 dots for this to see a good picture of what it looks like. So, well, 0 can be in the middle. Well, the next cube root would be 1 and then 8, right? But what can I do on the other side? Well, cube roots allow you to have negatives in there, correct? So I could do -1 and also -8. So keep that in mind, guys. The cube roots allow you to have negatives, so we need to worry about this. So this is -2, -1, 0, +1, and +2. So my graph is going to go -8, -2, -1, -1, 0, 1, 1, and then 8, 2. So it's basically going to do some form of like an S shape, if you can notice that. My domain, I am having negative infinity to infinity because we're going all the way left and all the way right. I'm going to do the same thing for range, right? Because this is going to keep opening up, both to the negative and to the positive. So we got that actually rolling for this cube root graph. We have both negative infinity to infinity on both domain and range. It's definitely a continuous graph. This one, though, if you notice, if I take this guy and I flip it over the y-axis and then flip it over the x-axis, it's gonna match. So this is an odd graph. For max and min, well, the absolute max would be infinity because it keeps going up forever. And then minimum's going to go negative infinity because it keeps opening down forever. There is not a local min or max because there is no actual hump or hill or valley, so we can't say there's any locals there. Intervals of increasing, if you look at it, I'm always increasing, always going up. So I am going to increase from negative infinity to infinity, but not decrease. As I go to the left of my graph, we're going down, so I'm going to go to negative infinity. And as I go to infinity, we're going to go to infinity. X-intercept is 0, 0 as well, as long as the y-intercept as well. Both of them are the same. So what does the shifting look like for a cube root? Well, still k is on outside, meaning up and down. H is still left and right on the inside, still opposite as well. A is my vertical stretch or compression, and then you still have the ability to reflect it in front of the function. So basically the same shifting rules as the square root graph. So let's try by making a table here. So first thing, I'm going to write down my, that should be -1. 1 and 8. And then I got -2, -1, 0, 1, and 2. So this is me putting my parent table down. So let's do some moving here. I got some right action happening, and I'm going to go up as well. So first I got to go right 2. Then I got to go up 1 as well. So this is going to be -6, 1, 2, 3, and 10. This is going to be -1, 0, 1, 2, and 3. So let's graph that. -6, -1, 1, 0, 2, 1, 3, 2, and then 10, 3. Doing some form of like that. Now notice, guys, this point right here, this middle guy, the one that caused the 2, 1 shift, the 0, 0 usually, that is called an inflection point. You might hear that word be used later as you continue in your math career, but that is a very special point. It's the middle of the graph. My domain, something cool and amazing about cube and square root just cube root graphs, sorry, it is negative infinity to infinity for my domain and range. Always. Never not that for a cube root graph. Okay? Let's try the last one for the night. So first I'm going to make notes. -8, -1, 0, 1, and 8. -2, -1, 0, 1, and 2. So I have a reflect happening, and I'm going left 5. So I'm going to go left 5 on all of these. Then I'm going to reflect, so that's going to multiply by -1 all the way down. So -8 minus 5, that is -13, -6, -5, -4, and 3. Okay. Multiplying by -1, that's 2, 1, 0, -1, and -2. So graphing here, oh, can't graph that guy. -13, 2 is like somewhere over here maybe. -6, 1 is right here. -5, 0 is right there. -4, -1, and 3, -2. So it's going to do something like this. Notice this is flipped because of the reflection. It's changing the graph around. And then again, my domain and range, because it's a cube root graph, is -infinity to infinity, which makes it super awesome for my graph. And that's the end of this video. See you later, Savers.